you want to probably, there's a good review in the book. So, you know, if you know you're taking Calc 1 and Calc 2, which is basically all of you, it's not a bad idea for you to buy the textbook. Binder version is cheaper, that type of thing. And then there's a great review. There's a review at the beginning in Chapter 1, and there's all this algebra review in the appendices in the back of the book. So it's not a bad idea for you to do that. I also like the idea of you doing an Algebra 1 and 2 class on Khan Academy. Some of you need trig again. You know, so if you end up with a C in Calc 1, it's not the end of the world, but you're not ready for Calc. Sorry, if you end up with a C in pre-calculus, it's not the end of the world. You're moving on, but you better patch up some holes, right? And you can always contact me over winter break and say, you know, having trouble with this. You're in a different Calc 1 class than mine next semester. You can always contact me, right? So just keep that stuff in mind, and then really try and fix some of the things that you know you're having trouble with over the break. So I've got a list of reminders here for our final exam. The last day for you to finish your Math Excel homework is Sunday, December 12th at midnight, basically, right? And remember, the homework pieces that I'm counting as your grade are when it says homework 001, homework 002, none of the other stuff, not the practice test, not the media and textbook, all of that. So just the homework up to homework for Chapter 6. Let me look at what those numbers are. I'm looking at my other screen here. Sorry, what's there? So the last homework number that I want completed by that Sunday. Okay, so there's homework 025. Oh, it's homework 026. So that's homework 001 to homework 026. You don't have to do anything else in the Math Excel, okay? So nothing else in that Math Excel. Let me take a look at your homework grades real quick. Let me turn off my screen share in case I accidentally... Oh, let me finish this checklist. So your final exam is Monday the 13th at 12:30. A little bit strange that we're starting at 12:30 instead of 12. But if you're a little bit early for the 12:30 time, that's fine. I'm planning on 15 problems max. So meaning, if I take the 2 hours and divide by 15, you get 8 minutes a problem. That's a lot of time. Yes, some problems might take 10 minutes, and then some might take 4. You just got to make sure that you're constantly working. And if you get stuck, it's a good idea to move on. Maybe something else will make it click. Look at your formula sheet. You got a front and back 2 pages. You should have some writing on there telling you what to do on a particular problem. And then you can always ask me a question, right? That's important. And then I've got my final list of what I think is going to be on there. I'm not sure about this one, but I'm pretty sure about the others. And even though I'm saying on test 2, you should know how to do problems 3, 4, 5, problem 1 and 2 on test 2 is a review of difference quotient. So be smart about what problems you're practicing on all the tests, right? Like for test 4, I know for sure 9 and 10 aren't on there because you all got them. I don't care if you got them already on the previous test. I'm not worried about testing you on that again, right? So that's you want to be conscious of that, right? Just because I say these are the problems doesn't mean you shouldn't look at the other ones as well, because they could be a review. Like I know in test 3, number 11 is another difference quotient, right? But should you do it? Yes, right? But I'm saying I've already covered all the difference quotient problems here. I'm saying there's different quotient problems on the test, right? I doubt there's more than one, but you never know. If I run out of things, I can always put a second difference quotient problem on for sure. Right? Test 4, 6, 7, and 8 are all trig identities. So even though I'm saying 6, 7, and 8 are on there, I might only have room for one trig identity, right? You have to use a conjugate, you have to use a LCD, you have to, clear fractions, everything we've been doing, right? So be smart about how you're studying. Now, I am on call all weekend via email. So if you have something you're having trouble with, you can send me an email. I'm pretty good right now. My girlfriend and my dog are visiting family in New Jersey, so I can answer things pretty quickly. I am an old man, so I will probably sleep from 10 o'clock at night till 5 in the morning. So if you answer something at midnight, don't expect a quick answer. But I will get back to you within in the hours of 6 in the morning till 9, 10 at night. I will get back to you as soon as I can. So any thoughts there on all of that? Everything clear? Yeah. Nice. Let me stop my screen share for a second, and let's look at your homework grades real quick, because I know we have some need for improvement in terms of our homework grades. I would love for you to shoot for a passing homework grade. If you have a homework average less than 70, I'm not giving you an extra credit point. If you have a passing homework grade, I'm giving you an extra credit point on an extra credit for the class. So get those homework grades at least above 70. I would prefer above 80. So 1, 2, 3, 4, 5. Only 5 of you have a homework grade less than what happened? Okay. Yeah, only 5 of you, so that's good. If you can get it to 80, 1, 2, 3, 4, 5, 6 of you have a homework grade less than 80. If you can get it to 80, it will really boost your grade. So I've got a student here with a homework grade of 60, and if they had a 99, they need only a 73 to pass with a B. In fact, an A is in. So this particular student says it needs an 97 on the final to get an A. But I mean, if you get an A on the final, and your final grade is a B in the class, and I've seen improvement, right? You're not going to stop me from giving you a higher grade than you earned, right? And you're not going to waste your time fighting it and say, I'm going to go to the grade committee and get it changed back to a B and all of that type of thing. So I'm saying, if you have a homework grade and you can increase it by 30 points, it's going to take some 20 some points off those min grades. If you can increase your homework grade by 30 points, it'll take those min grades down by about 20 or so, more than 20. So it's a real good idea for you to get some homework done, okay? So I'd say, take some time today, take some time tomorrow and Sunday chipping away at homework grades, but make sure you're hitting the problems on the old tests, right? Because a homework grade of 70 compared to a homework grade of 90, 70 on the homework and a solid 80 on the final will do you just fine. Okay? So don't get obsessed with homework and not study for the final. That would be bad. All right, let's get started. Let's get started on some problems to do. So the first thing I'm asking you to do is have some problems ready for me as I finish test 3. So as I finish test 3, I'll say anything you want me to do, and I'm happy to do that. If it's a direct problem on a test, you can just tell me what test and what number. If it's a concept, you can chat it to me, right? That's fine. My chat is open. Like one thing that a student in the other class asked for is short run, long run behavior, that type of thing, right? And so we did a problem. Jamal stayed late last class, and we did a problem on what do we do? It's a sign table. We're going to do one like that again today anyway. So from test 3. So, but again, anything you want to ask, please feel free. So here's test 3. And so I'm not sharing, sorry. So the review from this morning is already up there on Blackboard under announcements. So you certainly can watch that. I will let you know by the end of class if the stuff I'm doing is way different in this one. And so you could look at them. Again, anything you want from test 1 to test 4 that you want me to talk about once I do some important questions here, right? I think I started some test 3 last class, am I right? Did I do a one-to-one function and then find an inverse and all of that? No, we did not, right? Because we stopped at test. No. We stopped at end of test 2, right? Am I right?
Yep.
Okay, good. So I definitely like questions 1 to 4 as you know, maybe one question. I certainly can cut out the graphing because I'm going to ask you to graph for sure on something else, right? Like we did Wednesday. But then proving a function is 1 to 1 and then finding the inverse is definitely a possibility for a question. Do you want me to do this one or one similar to it? Because this one's here and you have the solution already, right? So
can you do that one, please?
Yeah, oh, sure. I'm happy to do that. So, exact problem, Elise, or one just like it, so that you have another one to practice.
Can we do another one like it?
Okay. Yeah. So that way, you've got right. You'll be able to look at this one and my solution, and then maybe look at the video and so you can hear the process again if you're right. If you're rather auditory is better. So I'm going to come up with a function. That's 1 to 1, and I'm not like the textbook. In the textbook will give you things that'll try and trick you to think it's 1 to 1, and it's not, right? So this is like test 3 number 2. And I've got f of x is equal to 2 minus 3x over x minus 5. And I would say something like this to you. I'd say prove this function is 1 to 1 and then find the inverse, right? Prove f is 1 to 1 and find F inverse. Oops. Okay, so how do we prove it? Well, graphically, not necessarily a proof. You could have made a mistake, but if you do it graphically and, right, let f of A equal f of B to show that A equals B, then you know you've got it, right? And so that's our process. So 2 minus 3A over A minus B, sorry, A minus 5 should equal 2 minus 3B over B minus 5. So what's our process now? What do we do? Remember, we're trying to show that A equals B. So I want A alone on one side, B alone on the other, right? So we're going to cross multiply. A lot of you on test 3 just canceled your denominators. I have no idea how, but it was good for a laugh then, and I know you'll do it right this time. So I'm going to cross multiply. And then there's no way around it, but what am I going to do? I'm going to distribute. Right? And you're not copying me here, you're erasing me. Don't let me go too fast. You know how to do every step we've done this semester, but remembering what to do is tough. And so when you're writing up your formula sheet, you want to give yourself some instructions, right? So now a bunch of things cancel here. The 10 on both sides will cancel. The 3AB on both sides will cancel. So it looks like I get 15A minus 2A equals 15B minus 2B. I'm trying to move things, all my A terms to one side, all the B terms to the other, trying to minimize the number of negatives. So 13A equals 13B, or A equals B. So it's 1 to 1. How's everybody doing there?
Did you move all the A's and all the B's to like one side?
Exactly, right here. So you can see this 2A moved left, became negative. This 2B moved right, became negative. Right, when I switch it aside, I switch the sign.
Oh, okay, yeah, I see.
Right, right. So now I know it's 1 to 1, I have to be able to find the inverse. Since F is 1 to 1, F inverse exists. Are we ready? Anybody need a moment? Nice, so I'm going to set my function, right? I know f of x is equal to 2 minus 3x over x minus 5. I'm going to set my function equal to y and solve for x. And this is the essence. I'm just switching the roles of x and y, right? The domain of f becomes the range of f inverse. So process is pretty damn similar. Cross multiply. Distribute. I'm trying to solve for x. Remember, I had it solved for y. I'm trying to solve for x. So I'm in all x terms on one side, and I'm trying to minimize the number of negative signs. That doesn't really matter. It just makes some of the algebra easier. So I'm going to move my x terms left, and then my y terms right. Factor out my x. And then divide. Switch x and y. And that's my inverse finally. Again, I do have the chat open, so if I'm asking you, am I going too fast and you don't want to say it, you can chat it to me. You say, yo, slow down. Well, what's the domain of f? X should not be what number?
5 to negative 3.
5, right? 5, right? And what's the domain of f inverse?
Negative 3. Negative 3.
X should not be negative 3, right? Notice, what's the horizontal asymptote of f?
Three.
Almost.
Negative 3.
Yeah, negative 3. Remember, we're doing the mother function of the numerator over the mother function of the denominator, and the x's cancel, right? So I get y is negative 3. You see the connection there? The domain of the inverse is the range of the original. Y becomes x, x becomes y. Only missing 2 students. How we do here? Elise, this help?
Yeah, thank you.
So what else could I possibly ask here to do compositions? Does anybody want to see that again? I would do the composition of f and f inverse and make sure I get x, right? And you want to see the composition again.
Please.
Yep. So I'm supposed to do both, right? But I'm just going to save a little bit of time just to do one of the compositions. What's really nice is if you graph these, and you should see the symmetry about, right, y equals x. That's a nice way to show it, but not so much a proof. So this is test 3, number 4. I've got f of x is equal to 2 minus 3x over x minus 5. And f inverse which I'm going to call g because I get tired of writing all of that, is 5x plus 2 over x plus 3. If f and g are inverse, then f composed of g is x must be true. In fact, more than that, right? More than that, I also must show that g composed of f is x, but I just want to do this one. So my outside function is 2 minus 3 times x over x minus 5. And you can see, make sure you can see this, that I'm writing the function f where my x becomes empty parens, right? On the top and the bottom, the x's become the empty parens. Because what am I going to put in there? The function g, right? In both of them. So I see I have fractions within fractions, and this is a big theme in Calc 1, is that if you have a fraction within fraction, or you have more than one fraction, you want to get a single fraction, completely factored numerator, completely factored denominator, right? And so the best way to do this is called a complex fraction, is to clear fractions. So I find my LCD over itself, LCD of just the interior denominators, right? Not the whole denominator, not this denominator, right? Not that whole one, just the interior denominators. And I'm distributing to every term, right? That same thing to every term. And I try to take my time here in that I am writing the original problem in black and the piece I'm distributing in purple. And things are going to cancel, but I'm not in a rush. See, this x plus 3 cancels with this, and this x plus 3 cancels with this. So I'm not in a rush. I'm not trying to do too much here. So now I'm just rewriting, not distributing anything yet. I know I have 8 minutes to do the problem, so I don't have to go too fast. I don't have time to sit there and space out, right? But, well, actually I did space out. I left space for all these factors when I was writing, but it's a joke. Now I'm ready to distribute. And things cancel. Oops, what did I do? Oh, it's just negative 13 there. You notice how similar this problem is to finding the inverse? I mean, you see some of the same coefficients, right? So because it's basically the same problem, right?
So, Professor,
Yeah.
will there be a composition one and a find the inverse one, or is it all going to be?
If
like
I
one
have
problem?
room, depends. Once I start making the test, I was supposed to make it last week, but I'm a bad employee, so depends on what I see happening, what I need. I know I had more. So on test 3, if you couldn't find the inverse, you couldn't do this one, right? And a lot of students had trouble finding the inverse. So it feels like I should put them both on, even though the algebra is so similar, right? Hey, and if you listen, if you only get 3 or 4 problems on the test that you had trouble with, right, on the previous test, good for you. You know, I can't. I'm not worried about a B student making the A. I'm worried about a D student making the C, right? So, or a student with a, you know, an F passing, right? So I'm just trying to make it as fair as I can and have you show me, and I'm talking to everyone, have you show me that, yes, now you can do the problems, right? I think I closed my test accidentally, sorry. I closed test 3 accidentally. Let me just log in again real quick. Okay, so 1 through 4, we're feeling pretty good about those. Let's do one like number 6, because I like number 6 on the test. So at the end of last class, Jamal and I did one just with a rational function inequality, but I can do another one like this. I wouldn't do both, right? But I'm definitely going to give you a rational inequality here. Let's do ln of. Oh, I got one here already done. So I like doing a problem just like the one that's on the test, because that way now you have 2 for sure that you can do again this weekend, right, without scrambling to find another problem or going into homework or the textbook or anything like that. So I want to find the domain of the following problem using a sign table. So this is test 3, number 6. Find the domain of f of x equals the ln of x squared minus 3x plus 2 over 2x squared plus 5x minus 3 using a sign table. Now wait till you see how easy we make these sign tables in Calc 1. But I'm trying to really get you the understanding of what's going on. So I do the sign tables in pre-cal with a lot more detail, because I know if you can do them then in pre-cal, then the one I do in Calc 1 and Calc 2 is so much quicker and easier, but it's hiding some of the details of what's really going on. And so that's why I kind of torture students in pre-cal with it. But then once you get to calculus, you're like, oh, I can do that. It's easy. So what's the key here? If ln of g of x is the function, then g of x must be what?
It's inside ln.
Yes, it is inside ln, but there's what do I know about the values that go inside of ln?
The critical values.
Yes, you're right. I'm trying to find critical values. But looking at my ln function here, what do you notice about the domain?
It stops. It doesn't go past a certain point.
Good. And what point is that? Where's that?
0.
Exactly. So g of x must be greater than 0. So what we're really looking at is this g of x equal to x squared minus 3x plus 2 over 2x squared plus 5x minus 3 is greater than 0. That's what I need to happen to get this domain. So what do we have to do with g of x? Jamal, you already said it. We have to find the criticals, but I got to do something before. Got to do something before that. Factor, exactly. So what do I get? What are my factors upstairs?
You get x minus 2, x minus 1.
Nice. Downstairs, it's a little bit more difficult to see. I don't care how you factor it. If you're a guess and checker, just don't tell me you're guessing and checking. I might vomit. I like to use the AC method. So I know that AC is 2 times negative 3. That's negative 6. And the factors of 6 are 1 and 6 or 2 and 3. That's it, right? And to get a negative, I need one of the factors to be negative. So I'm looking for one of those rows to give me a positive 5. Right? And that's obviously this one. Right? I need that middle coefficient to come from the sum of the factors of AC. And then we split the middle term. So 2x squared plus 5x minus 3 becomes 2x squared minus 1x plus 6x minus 3. And then I can take out a 2, and I can take out a 3. And I see a repeated factor of 2x minus 1 and leftovers of x plus 3. It's not easy to shortcut that. But some of your teachers may have taught you that cross method where you're really just guessing and checking. I don't care how you factor at this point. This is a nice one to do with synthetic division, right? If I did this one on if I took my function, right, and graphed it, I would see it goes through negative 3 and it goes through positive 1/2. This is why. So I don't know how to factor, but I do know how to synthetic divide. So I graph that downstairs function. I see it goes through -3, and I do synthetic with it. That would be impressive if you did that. And look what you see. Look at what you see. What's that factor?
2x minus 1.
And if I have a 0 of -3, what's the factor?
X plus 3.
Nice. All right, now we're ready for our critical values. Is everyone okay? My chat is open. Nice. So critical values are when the numerator equals 0 or the denominator equals 0. And then next semester you're going to have critical values of a derivative. And guess what? That's when the numerator equals 0 or the denominator equals 0. And then you're going to have critical values of the second derivative. Same thing, where the numerator equals 0 or the denominator equals 0. So all of this stuff, everything we're doing is going to keep happening, okay? Unfortunately, right? So what do we see as critical values? What's the smallest one?
-1/2.
Yeah, positive 1/2, right?
Or positive 1/2.
Yeah, I need a -3, a 1/2, and then the upstairs are easy, right? A 1 and a 2. So I like really kind of mimicking my number line in like second grade, whatever grade it was. So here's my number line on my desk, but I've made these things so that I'm showing that if I'm walking on that number line, if I get to the -3, I fall through the hole, right? Because I can't use them. I can't use these values. Why can't I use the -3? Why can't I use the -3? What will it do to the function inside?
Make it undefined.
Undefined. Can't do anything with it even by itself. And what will I do with the positive 1? What's going to hurt me about the positive 1?
Zero's not greater than 0.
That's right. ln of 0 doesn't exist, right? If I put it in my calculator, it says low battery, or it says what the hell you doing, or right? So I'm looking at my number line, and I know it's going to positive infinity to the right and negative infinity to the left. And these values all create my column separators. The values of the criticals and the endpoints of my domain, even though negative, positive infinity is not an endpoint, but and then what becomes my row separators are all my functions. All my factors, sorry. And I had what, an x minus 2, an x minus 1, 2x minus 1, and an x plus 3. And the product or quotient of all of those will give me the function g of x. And I'm interested in g of x being positive, right? So I'm looking for a positive sign in that bottom row. What's next? Who remembers? Don't let me go too fast.
So we multiply them then and see what's negative for positive if you get a negative or positive.
Well, yeah, one step before that.
Pick numbers between those criticals.
Exactly, the test values, right? So I need test values between, left of, and right of all my criticals. So for example, -4 is left of -3. 0 is between -3 and 1/2. 3/4 is between 1/2 and 1. $1.50 is between $1 and 2, and 3 is bigger than 2. So I can pick anything I want, and I really want you to see why. Because if I cheat this a little bit and draw my graph real quick, just a rough sketch, right? I know I have a vertical asymptote at -3. I also have a vertical asymptote at 1/2, right? And I have a horizontal asymptote of 1/2. Do you agree with that one?
Yes.
So I kind of have like little regions where I've got to check and see what's happening to my function, right? So, but anyway, I'm gonna do a quick sketch. Just let me use Desmos. So I've got y equals the ln of x minus 1, x minus 2, all divided by 2x minus 1, and x plus 3. So you can see that I've got a bunch of regions. Where are my little pieces that I'm interested in looking at x equals -3, right? You can see that's one of my vertical asymptotes. I had another one at x equals 1/2, right? So there's a green vertical asymptote there. There's another critical for me at 2 and another one at 1. Even though they're not vertical asymptotes, I'm going to put them in at x equals 1 and at x equals 2. So you can see that I'm cutting off all these regions, right, that could be trouble for me. I really should have factored not the ln. Let me see if I can do this. I really should have just drawn this thing, because now, oops, come on. Now I can see the whole function. And remember what I'm interested in. I'm interested in the function above ground, right? I'm interested in the values of this when the red curve is above the x-axis. That's the function g. I want g to be positive so I can put those values into the ln function. So you can see my first piece on the left is above ground, right? My second piece, right, is below ground. My third piece is above ground, and then it dips underneath the axis just a tiny bit here on that next piece, right? It's hard for me to stretch it out because, oh, there it is. I can see it right there, right below again, and then back above again for the fifth piece. And look at my columns here. Look at my columns. How many pieces do I have there on my columns? How many columns do I have that are empty? 5. Those are the 5 regions where I'm going to find out if that inside function of the ln is above ground or below ground. If it's above ground, I like it. I can use it. If it's below ground, I can't. Right? I need the ln of g of x. I need g of x to be 0. I mean bigger than 0. So I'm ready to, so I kind of have these little separate regions here. Here's 1, here's 2. I already know that the function's above ground here, below ground here, above ground here, below ground here. Oh, I know what I did. sorry. I'm just going by my sketch, right? So above. Yep. Below. And then above again. Something like that. You get the idea. Where did I lose it? Oh, yeah, right here, sorry. This piece. Above, below, above. Right? So now look at the picture of where I'm testing -4. Here's -4, right? I'm going to test -4, but what it's going to give me is going to give me a point on the curve. It's going to give me a point on the curve. I don't care what height it is. In fact, what height is it? Don't tell me because I don't want to do it. I don't care what height it is. I only care about, is it positive above ground or is it negative? So when I plug in, so I already know the answer is positive because I can see it on the graph. I can see it's above ground. When I put a -4 into the function, I'm moving up, right? So, but if I put the -4 and I get a negative, a negative, a negative, and a negative, an even number of negatives in factors of a rational function will always give me a positive. An odd number of negatives will give me a negative. Oh, I got my graph a little bit wrong. It doesn't matter. You get the picture, right? I think. Who did I lose? Who left? I lost Amir? Amir, are you still here? No, I lost Amir. So when I plug in 0, right, I get what? Negative, 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 positive. So that piece is negative. Isn't that clear here? Isn't that clear? When I plug in a 0, I get a point underground. Right? You see it? When I plug in 0. Now, would it matter if I plugged in 1 there? Is 1 a good test value there? Is 1 between -3 and 1/2? Yeah. -3 is smaller than 1, which is smaller. I'm sorry, -1. Sorry, thank you, Elise. What if I plugged in -1? If I plugged in -1, do I still get a point under the ground? What if I plugged in -2? Do I still get a point underground? That's why it doesn't matter which, as long as I'm between the criticals, I can test any test value I want. So when I plug in 0.75, I get a negative, positive, a positive, so positive. So far these two intervals for me are good, right? When I plug in 1.5, I get a negative, positive, positive, positive. And when I plug in 3, I get all positives. Is this clearing anything up for anybody with this sine table hell that I'm putting you through? So there's 3 intervals that work for us, but those intervals are coming from the criticals, right? They're coming not from the test values. They're coming from the criticals. So f of x equals the ln of g of x has the domain of -infinity to -3 union 1/2 to 1 union 2 to infinity. I realized I screwed up my graph here. I see it now though. How are we doing? You okay? So I'm not going to give you one like 7. I am going to give you one like 8. So I've got another one prepared here. Are we ready? Do you need to go back to the other screen?
Can you go back for a second,
Absolutely.
please?
Yep. You need to see at the end here, and you need to see earlier, and then make sure you ask me a question if you're not clear about something. I mean, you think this question might seem long, but I know in Calc 1 we'll have some questions that are 2 or 3 pages long. Same with Calc 2. I was using so much paper when I transferred to university because I did every problem that it was cheaper for me to buy a big, whiteboard with markers. Okay, we ready? Lise, yes?
Yeah, thank you.
Yeah, no problem. So on so I like number 8 on the test. On this test, I don't like number 7. But let me do a different one. A lot of students had trouble with this. So we want to solve this for x in terms of ln's, solve it for x with a single logarithm using a change of base, and then get a decimal, and then we can check that decimal on our calculator as well. So let me do a different one than this. So solve for x. I've got 3 to the 5x minus 2 equals 2 to the 6x. So we're going to take the ln of both sides. Why are we allowed to do that?
Is it because of the exponents?
What kind of function is ln? What kind of function is exponential?
One to one.
1 to 1, right? 1 to 1. Like is negative 2 squared equal to 2 squared, right? Is that true? Negative 2 quantity squared is equal to 2 squared, right? So can I take a square root of both sides here? If it was true, we would have this, right? And then we would have this, right? So what's the issue there, right? Which of my functions that I had are not 1 to 1 in this original problem? Which two functions did I use?
Negative 2 to 2.
Okay, squaring. I'm using the x squared function. And what's the other function I used?
Root 4.
Square root. Square root. Just what operation am I doing? I'm squaring something, and then I'm square rooting something. But the problem with x squared, it's not 1 to 1. Square root of x is, but x squared is not. So I'm only allowed to compose these functions with each other like this when they're continuous and 1 to 1. Continuity we'll talk about in Calc 1, but there's no breaks in ln or exponentials, right? So now I'm using properties. So the 5x minus 2 in parens comes down as a coefficient. And the other side, I'm just going to bring down the x. Is that okay? You okay if I just bring down the x? You see any problem with that?
How come you wouldn't bring down the 6x?
I can. And so I don't mind finishing it this way, but you'll see later on, I'm going to bring that 6 back in as an exponent. But that's fine, we can do that. I'm going to distribute sometimes I write the parenthesis around the argument of ln, sometimes I don't. When it's confusing, I always do. When it's like ln of 2, right? There's nothing wrong with just writing ln of 2. There's no doubt about it, right? But when it's ln of like x plus 2, that one doesn't look the same to me at all, right? So I've got to be careful there. But when it's obvious that there's a single term argument, I'll skip writing the parenthesis of the function, right? So I want all my x terms on one side, trying to minimize the number of negative signs. And I'm factoring out the x. So now you can see I can move all these these coefficients back in, right? I get ln of 3/5. Forget what it is. Sorry, 3 to the 5. 243. Minus ln of 2 to the 6, that's 64. Equals ln of 9. So x equals ln of 9 over ln of 243 minus ln of 64. And of course I could do one more thing there, right? I could make a product there downstairs, ln of 9, quotient of ln of 243 divided by 64. That one looks a little funky to me, so I'll put those function parentheses back on. So there's an exact answer in terms of ln's. How can I write the answer in terms of a single log? I've got a base of 243 over 64 and an argument of 9. Log base 243 over 64 of 9.
Professor?
Yep.
How do we go from where we factor out the x to the ln 243?
Yep. So log of A over log of B equals the ln of A over the ln of B. Oh, wait a minute. Jamal, say it again.
I said, how do we go from after we distribute it to the next line? So the x parentheses ln 243 minus ln 64.
Yes. So when I'm subtracting logs, I'm dividing the arguments. Just like when I'm dividing like terms, I'm subtracting the exponents. Right?
Got it.
And there's my change of base formula. And then, of course, I can use the first one, right? I can use this first one as an approximation. So ln of 9, close paren, divided by ln of 243 divided by 64, 1.646874693, or approximately 1.65. Do you want to see this answer as found on the calculator? Yeah. The other class didn't. I didn't know why. I'll wait for you, Jamal. Okay.
You said what?
It looked like you were still copying it, so I was just waiting for you.
Oh yeah, I'm good.
Okay. Nice. I want to show you how to get this answer on the calculator. Of course, we're going to get the approximate answer only. So I got my calculator open, and I'm going to put in y equal, I'm going to put in that left side, which was what? 3 raised to the 5x minus 2. And in y2, I'm going to put the right side, 2 raised to the 6x. And then I want to make sure I graph it and make sure I see where the two functions are crossing on the screen. So I zoomed. I'm just going to zoom in. Since my answer was 1.65, I'm just going to zoom into the origin. Oops. So graph, zoom, in, 2. I don't have to do this. I can just assume, because I got an answer, that they're crossing, right? Why didn't I get a negative answer? Did I make a mistake somewhere? Oh, they're crossing above, right? I'm in between 0 and 1. So let me just change my window height. To 50. I think it would work on this. I just need my X. I need my X's. So I should see them crossing up here. Oh man, it's not working. They cross up there. You can see it. They cross up here. Let me see if it works this way. Let me try it before I tell you the process, okay? Second, calculate intersection. Enter, enter, enter. Okay, it worked. Okay, so let me do it this way. Go back to graph, zoom standard, okay? Sorry, zoom standard. So zoom 6. That gives me a picture of the two graphs, and I'm showing the x value that I think is my answer, and that's what's got to happen. Okay. So then I do second, calculate intersection. Second, calculate intersection. Then it's saying, is this your first curve? Enter, yes. Is that the second curve? Enter, yes. What kind of jeans do you wear? It says guess, no. That means guess the right answer. And then it will give me the answer, 1.65. Okay? Good. Just one more to do today. So in that test, 9 is going to happen in question type 9 will happen in the question in chapter 4, test 4. So I don't need to give you something else like that. I am not giving you a secant slope with trig. Question 10 is the one we should do. So I'm going to do a different one than this, and then we can quit today. Okay. Look at question 11. So did I say question 11 would be on the test? No, but it's a difference quotient, right? I was saying that before. Make sure you look at all of the problems. There's a few for sure I said I'm not doing, right? The others I didn't mention because guess what? They're similar to the questions I am asking. So that means you can still do those, right? And you can always drop me an email saying, should I do this problem? And then I would ask you, send me a picture in that case. Don't say, should I do test 3, question 9? Because I could be somewhere. I could be shopping, and I could be in the grocery store. And if you gave me the picture, right, while I'm waiting online to pay, I could just say, no, don't do that. But if I have to go open the Blackboard and get the test and look at the question, you know what I mean? Make it easy for me to answer something. All right, question 10. So let's graph y equals 3 times the cosine of 2x minus pi over 3. And you should remember that I want to factor out that frequency. Factor out that frequency. That's the way I taught it. The book teaches it differently. The book teaches you to do it with the frequency still distributed into there. So what's our amplitude?
Three.
Mm-hmm. What's our frequency?
2.
Mm-hmm. What's the period?
Pi over 6.
Nope, 2 pi over 2. So it's 2 pi over the frequency for sine and cosine. What is our start value? Oh, I'm sorry, what is our quarter step?
Pi 4.
Yep, it's a period over 4. What's our start or phase shift? over 6. Right? It's the piece that makes this 0. Horizontal shift. Let's take our first step. The first step is the start plus a quarter step. So pi over 6 plus pi over 4. And for that, what do I get? 5 pi over 12. I'd like my start and my first step to be brother and sister, so I'd like the same denominator there, right? So what is that? 2 pi over 12. So I can see from my start at 2 pi over 12 to my first step at 5 pi over 12, I'm just adding 3 pi over 12. So that's all I have to think about as I do the rest of the pieces, right? So my start and steps, 2 pi over 12, 5 pi over 12, 8 pi over 12, 11 pi over 12, ending at 14 pi over 12. So, I mean, when you have this one prepped on your formula sheet, you need the comments. You need to know what they are, or unless you have it memorized. So we're going to graph, and we want to see the graph in a nice scale. So I'm going to scale to pi over 12s, and then I'm going to scale to 3, right, for my amplitude. So I've got my 1 pi over 12, 2 pi over 12, 3, 4, 5 pi over 12, 6, 7, 8 pi over 12, 9, 10, 11 pi over 12, 12, 13, 14 pi over 12. So these pieces that I've extended are giving me my quarter steps and the width of my rectangle, and the amplitude's giving me the height of the rectangle. And I know cosine starts up here, right? It's the smile one, yeah. Of course, it keeps going. And I like some labels. So this is x, this is y. The function is y equals 3 cosine of 2x minus pi over 3. I can, of course, label my ticks. I don't want you to reduce. Don't bother reducing. We did all that work to not reduce in order to find all these quarter steps quickly.